Good morning, students. Exercise 9.9, third problem. Find by integration the volume of the solid generated by revolving about the y-axis. The region enclosed by x squared is equal to 1 plus y and y is equal to 3. See, the area of the region bounded by the curve x squared is equal to 1 plus y and y is equal to 3. This area is revolved about y-axis. We are getting a solid and we are going to find the volume of the solid by integration. Okay, so here the curve is given x squared is equal to 1 plus y. So on seeing this equation, we can easily identify it's a parabola open upward. Okay, so anyhow we'll make a tabular column and get 5 or 6 points, then we'll draw the diagram. So first step, put x is equal to 0. If you substitute x as 0, your 1 plus y is equal to 0. So y is equal to minus 1. And put y is equal to 0. If we substitute y as 0, x squared is equal to 1, x is equal to plus or minus 1. So for two values of x, that is 1 and minus 1, your y value is 0. So you will get a point 1 comma 0 and minus 1 comma 0. Next is a substitute, x is equal to 2. If you substitute x as 2, it is 2 the whole squared is 4. 4 minus 1 is 3. Okay, if we substitute x as minus 2 the whole squared also 4. So bring this 1 to the next side, 4 minus 1, y is equal to 3. So 2 comma 3 and minus 2 comma 3. So using the points, we just mark it here. So 0 comma minus 1. See that this point is 0 comma 0. Okay, and below that this point is 0 comma minus 1 and 1 comma 0. So you will have 1 comma 0. In the same way, minus 1 comma 0, 2 comma 3, and this is 2 minus 2 comma 3. And the same way, if we substitute 3, so 3 means 9. 9 minus 1 is 8. So 3 comma 8, and the same way minus 3 comma 8. So 4, if we substitute, it is 16 minus 1, 15. So 4 comma 15 and minus 4 comma 15. So the right side of y-axis and the left side of y-axis, the same distance you will have the points. So therefore you will get a curve with the parabola which is open upward. Okay, and you have to mark the line y is equal to 3. So y is equal to 3. So this point is 2 comma 3 and this is minus 2 comma 3. So therefore you have to draw the line through this point, that is y is equal to 3. And you will have the lowest point of the parabola, that is the vertex 0 comma minus 1. So through that point, if you draw the horizontal line which is parallel to x-axis, which pass through the point 0 comma minus 1, so whose equation is y is equal to minus 1. So what is given here? This area bounded by the parabola, you see that, bounded by the parabola, y is equal to minus 1 and y is equal to 3. So this part is how it is. It is revolved about y-axis. You will get a solid. You will get a solid and you are going to find the volume of the solid. So therefore the volume of the solid is, which is revolved about which axis? Y-axis. So integral c to d pi x squared dy. So see the limit, it varies from y is equal to minus 1 to y is equal to 3. So y is equal to 3 alone is given in the problem. So you have to take the lower limit. So it is the lowest point. So between, so through this point only we have to draw the line. So whose equation is y is equal to minus 1. So therefore y is equal to minus 1 to y is equal to 3. Okay, so the lower limit is minus 1, upper limit is 3. This pi is a constant, it is taken out. You have to take x squared. So the curve is, parabola is x squared is equal to 1 plus y. So in the place of x squared, you have to substitute 1 plus y. So if you integrate this, y, it's a constant into dy. So therefore it is y. Plus if you integrate y, it is y squared by 2. And you have to apply the upper limit. So you see that in the place of y you have to substitute 3 plus 3 square 9 by 2 minus you have to apply the lower limit, so in the place of y you are having minus 1 plus minus 1 the whole square is plus, that is 1 by 2. If you take LCM 6 plus 9 is 15 by 2 plus here half minus 1 is minus half, so minus half into minus is plus half, so 15 by 2 plus 1 by 2 is 16 by 2, 16 by 2 is 8, so it is 8 by cubic units. So the next one we are moving to the fourth problem. You see that the region enclosed between the graphs of y is equal to x and y is equal to x squared is denoted by R. So you see here one line y is equal to x is the line, okay, and y is equal to x squared, it's a parabola. So the area between the line and the parabola is denoted by R. You see, you are going to find the volume generated when R is rotated through 360 degree about x-axis. So the area R when it is rotated about x-axis, one full complete rotation, that is through 360 degree, if the area R is rotated about x-axis, and what is the volume you are going to find. So first we have to draw the line and the curve in the diagram. So for that you have taken x-axis as well as y-axis. So you see that first I will draw the y is equal to x, the line. So whatever value you give for x, that is the value of y. So put x is equal to 0 and y also 0. Put x is equal to 1. So x is equal to 1. Okay, here you will have x is equal to 1 and y also 1. So the point 1 comma 1. X equal to 2 means y also 2. X equal to 3 means y also 3. So therefore this red color line is the identity line. Identity function it is. So this is the line y is equal to x. So the red color line is passes through the origin, that is y is equal to x. Okay, next we have to draw the parabola y is equal to x squared. For that I will take some points. Put x is equal to 0. If you substitute x as 0, y also 0. Put if you substitute y as 0, x squared is equal to 0, so x is equal to 0. You will get the same point. So that's why I didn't substitute y as 0. So see now, put x is equal to 1. 1 squared is 1. Okay, put x is equal to minus 1. Minus 1 the whole squared also 1. Put x is equal to 2, it is 4, and minus 2 if we substitute it is 4. So therefore 0 comma 0, 1 comma 1, the same way minus 1 comma minus 1, minus 1 comma 1. At the next 2 comma 4, if you have 2 comma 4, here also minus 2 comma 4, and if you have 3 comma 9, so 3 comma 9 means here also you will have minus 3 comma 9. So you have to draw the, that is the blue color line is the parabola which passes through the origin y is equal to x squared. See that the parabola and the line. So this is the area. Here I have shaded with green color, that is the area between the line and the parabola. So it is denoted by R. Okay, so when this R, this area is rotated about x-axis, one full complete rotation, you see that this part is called the volume. This part is nothing but the solid. Okay, this area R, the shaded part, when it is revolved about x-axis, one full complete rotation it makes, means you will get a solid. So here I have drawn the solid. So this part. Okay, so we are going to find the volume of the solid. Okay, so it is rotated about which axis? It is rotated about x-axis. Okay, it is rotated about x-axis. So therefore the volume is equal to, what formula we have to use? Integral a to b pi y squared dx. Here you see that here the area between the line and the curve. So therefore you have to choose the limit. It's from x equal to 0 to x is equal to 1. So this is the line x is equal to 1. So therefore integral. So before that we have to find the point of intersection. So you have to solve the two equations. So here y is equal to x and y is equal to x squared. So if we substitute here y as x, so x is equal to x squared. So x squared minus x is equal to 0. From this x, if you substitute, if you take out, it is x minus 1 is equal to 0. So therefore x equal to 0, x is equal to 1. When x is equal to 0, y is equal to 0. X is equal to 1, y also 1. So therefore the point of intersection of 0, 0 and 1, 1. So that's why here I marked 0, 0 and 1, 0. So this area, the shaded part is R. When it is revolved about x-axis, so you will get this solid. And we are going to find the solid. So we are going to find the volume of the solid. So the required volume is integral 0 to 1 pi y1 square dx minus integral 0 to 1 pi y2 squared into dx, because here two curves are involved. So therefore volume, required volume is equal to, from these two what is common? So the integral 0 to 1 and pi also common. If it is taken out, it is y1 squared minus y2 squared into dx. So if two curves, that is line and the curve given, it is about x-axis, the area is nothing but integral a to b y1 minus y2 into dx. Here volume means pi into y1 squared minus y2 squared into dx. We have to choose y1. That means the y has to be chosen from the first curve, and y2 means y has to be chosen from the second curve. So for that we have chosen the x-axis. So any arbitrary line you have which is parallel to y-axis, and if you draw it, first it touch the red color line, then only it will touch the blue color curve. So therefore the first y has to be taken from the line and the next y has to be taken from the curve. So therefore here from this line your y is what? X. So here y1 squared, so therefore x squared minus the second y has to be taken from the curve. So here you will have x squared, y is x squared, but here you have to write y squared, so it is x power 4. And if you integrate x squared, it is x cube by 3, and x power 4 if you integrate, it is x power 5 by 5. You have to apply the upper limit, so it is 1 by 3 minus 1 by 5, and the lower limit is 0. So here also you are having both the terms having x, so therefore the lower limit is 0. If you take LCM, the LCM is 15, so the numerator is 5 minus 3, that is 2. So 2 pi by 15, that will be the required volume. So next one, fifth one, find by integration. So find by integration the volume of the container which is in the shape of a right circular conical frustum as shown below. So this it's a right circular conical frustum. Okay, so we are going to find the volume of this container. So first you should know about what is frustum. Okay, so frustum is nothing but a right circular cone when it is divided by the line, parallel to the base. So right circular cone when it is divided, when it is cut off the line which is parallel to the base, you will get a frustum. So here I have drawn the line which is parallel to the base. So the right circular cone is cut. So when it is cut, you see now you will get two parts. One is the upper part of the cone. Another one is called the frustum. So this part is nothing but the frustum. You see now here, see the full cone is cut off by the line which is parallel to the base. So the upper part is cut off. The remaining part is called the, what is it, frustum. So here it is drawn. So the container is in the shape of a frustum. Okay, you see now here 1 meter, this distance is 1 meter, and here you will have 2 meter, this also 2 meter, and see here this angle is 90 degree. So it is given in the book. So I have taken this. You see now here it is 90 degree, means I have taken the horizontal line as x-axis. Through that I have drawn the vertical line, so that is y-axis. Okay, see here this is the origin. So this distance is 1 meter. So therefore the point is 1, 0. And from B, if you draw the perpendicular line, so whose distance is 2 meter, because this one is parallel to this line. So therefore this length is 2 meter, it is given. So this also 2 meter. So therefore we can write this point B from origin is 2 meter. Why it is 2 meter? Here also you are having 2 meter, so that's why it is 2 meter, and this y distance also 2 meter. So therefore the B point is 2, 2. See the shaded portion is revolved about which axis? Y axis. You will get the frustum, that is a container. So and you are going to find the volume of it. Okay, for that it is revolved about which axis? Y axis. This shaded part, that is a orange color shaded part, is revolved about which axis? Y axis. You will get the whole thing. Okay, and see that it is integral. What is that? The formula integral a to b pi x squared dy, because it is revolved about which axis? Y axis. Okay, see now first you have to find the see that for this formula you need which one? X squared. So for that we need some equation. So here a point is 1, 0 and your b point is 2, 2. So if you join these 2 points, you will get a line AB. So we can find the equation of AB. Okay, so the equation of the line AB is using the formula 2-point formula, y minus y1 divided by y2 minus y1 is equal to x minus x1 divided by x2 minus x1. So the A point is 1, 0 and the B point is 2, 2. If we substitute, what is y1? 0. So y minus 0 divided by y2 is 2, 2 minus 0, which is equal to x minus 1 divided by, what is x2? This is 2 and x1 is 1. So 2 minus 1. So y by 2 is equal to x minus 1. So y is equal to 2x minus 2. So which part? The area bounded by this line. This line equation, what it is now? It is nothing but, what is it? Y is equal to 2x minus 2. So this line and y axis, and y is equal to 0. You see that y coordinate here 0. So y is equal to 0 and y is equal to 2. So because this point is 2, 2, so here y is 2. So area bounded by the line y axis, y is equal to 0 and y is equal to 2. This part is revolved about which axis? Y axis. We get a container which is in the shape of a frustum, and you are going to find the volume of it. So integral, where is from 0 to 2 pi x squared dy. So pi is a constant, it is taken out. Now you have to substitute x squared. Okay, see you need x first. So from this equation, this minus 2, when you take it to the next side, it is y plus 2 is equal to 2x. So what is x? X is equal to y plus 2 divided by 2. So here in the place of x you have substituted y plus 2 divided by 2. Here x squared, so therefore the whole squared. You see now. So therefore you are going to integrate. So see, y plus 2 the whole squared. If you expand, it is a plus b the whole squared. So therefore y squared plus 4y. So I have written 2 squared. If 2 squared is 4. So 4 is a constant, it is taken out. Now you are going to integrate y squared. So that is y cubed by 3. And plus 4 is a constant. If we integrate with respect to y, it is 4y, and plus 4 is a constant. If you integrate y, it is y squared by 2. Okay, and you have to apply the upper limit. So here in the upper limit is 2. So if you substitute 2 cube, so 2 cube is 8 by 3 plus 4 into 2, that is 8, plus 2 and 4 getting cancelled. So the numerator you will have 2. And if you substitute in the place of y, it is 2 squared. 2 squared is what? 4. 4 into 2 is 8. Okay. And you see all the terms having y. So when you substitute x, that is y as 0. So the lower limit is 0. So it is 8 by 3 plus 8 plus 8. What is 8 plus 8? That is 16. Okay. If you take LCM, the LCM is, so the LCM is 3. So therefore it is 8 plus 48. 16 3s are 48 by 3. So 8 plus 48 is 56 by 3. So in the 4 and 56 if you cancel, it is 14. So 14 pi by 3 cubic units. Okay. So the next one, sixth problem. A watermelon has an elliptical shape which can be obtained by revolving an ellipse with major axis 20 centimeter and minor axis 10 centimeter about its major axis. You see that it is revolved about its major axis. Find its volume using integration. You see the watermelon is in the elliptical shape. Okay, so what is given? The major axis is 20 centimeter. So the length of the major axis is 20 centimeter. What is the major axis? We have taken the major axis along x-axis. So therefore the length, the major axis is what? A dash. So A dash is along x-axis. So A dash is nothing but what is given? 20 centimeter. So length of the major axis is 2a. So 2a is equal to 20. A is equal to 10. So therefore this point is 10, 0. And here you will have this point minus 10, 0. So from a dash to a, this distance is, what is it? 20 meter, 20 centimeter. And minor axis is 10 centimeter. Which is minor axis? B dash. It is along y-axis. So B dash, this distance is 10 centimeter. It is given. So the formula of the length of the minor axis is 2b. So 2b is equal to 10. B is equal to 5. So what we have considered? Your major axis lies along the x-axis. So therefore the equation of the ellipse is x squared by a squared plus y squared by b squared is equal to 1. So what is your a? A is equal to 10. So that in the place of a you have to substitute 10. 10 squared plus y squared by, in the place of b you have to substitute 5 squared is equal to 1. So x squared by 100 plus y squared by 25 is equal to 1. So the what is it? The ellipse is revolving about its major axis. So therefore it is revolved about x-axis. So the formula is, what is it? Integral a to b pi y squared dx. So for that we need y squared. So therefore here from this equation I have arranged y squared. So y squared by 25 I kept it on the left side. here you are having 1, bring this term to the next side, minus x squared by 100. If you take LCM, the LCM is 100, so it is written in the denominator. If you take LCM, 1 into 100, 100 minus x squared by 100. This 25 in the left side and the denominator, so when you bring it to the right side, it is in the numerator. So therefore 25 by 100 into 100 minus x squared. If we cancel, it is 1 by 4 into 100 minus x squared, that is y squared. From the equation I have found y squared. See that this ellipse is revolved about its major axis. So see now, when this part, that is OAB, the area in the first quadrant is revolved about x-axis, you will get this part. Okay, and this part is revolved, you will get here the whole thing. So therefore what I am going to write, I am going to write as 0 to 10. So it is symmetrical about both the axes. So it is symmetrical about both the axes. So that's why I'm going to find the required volume as 2 into integral 0 to 10 pi y square dx. Why this 2 has come? Otherwise we have to take the limit from minus 10 to plus 10. So it is symmetrical about x-axis as well as y-axis. So that's why I have written 2 into integral 0 to 10 pi y squared into dx. Okay, so pi is a constant, it is taken out. Already we have found it is, what is it? It is your y squared is, what is it, 1 by 4 into 100 minus x squared. So when you substitute here, so this 1 by 4 is taken out. So 2 pi by 4 into, you have to integrate 100 into dx. So that is 100 into x minus x squared. If you integrate, it is x cubed by 3. And the limits varies from 0 to 10. So if you apply the upper limit 10 here, it is 1000 minus 10 cube, what is it, 1000 divided by 3. When you apply the lower limit, it is 0. If you take LCM, 3000 minus 1000 divided by 3. 3000 minus 1000 is 2000 by 3. So here 2 pi by 4 can be written as pi by 2. So this 2 and 2000 getting cancelled. So here you will have 1000 pi by 3 cubic units. Instead of writing 2 into, you can write integral minus 10 to plus 10. So therefore the whole part is revolved about x-axis. Okay, and you can vary minus 10 to plus 10. So here your y squared is even function. So this can be written as 2 into integral 0 to 10. So here I have taken only this area is revolved about x-axis. You will get this part. The same way, this part also is revolved, you will get this. So either you can vary the limit from minus 10 to 10, or otherwise 2 into integral 0 to 10 pi y squared dx. Any one result you can follow it. Thank you, students.